In this video, we'll continue our discussion of triple integration by working another example. So again, this is just a setup problem. Set up a triple integral for the volume of the solid bounded by, okay, we have that surface, and z equals 0. So z equals 0, remember, this is our xy plane. So with that, if I'm worried about the xy plane, I would like to know where this thing intersects the xy plane. Well, if I want to know where it intersects the xy plane, I'm going to put a 0 for z. I'll work this out. Okay, let me write all this down. Now, if I square both sides, I got 0 equals 4 minus x squared minus y squared. If I square a 0, I get 0. And then if I square the right side, it gets rid of the square root. If I add x squared and y squared to the other side, I got x squared plus y squared equals 4. And that was my circle right here that I didn't want to redraw. All right, so we're dealing with a circle on the xy plane. That's where this surface intersects it. I don't know if you can see this, but if I were to manipulate this a bit, I could get this to x squared plus y squared plus z squared equals 4. This is a sphere with radius 2. So what we're actually dealing with here is a hemisphere sitting on top of the xy plane. Okay, so let's write down our bounds. I like to list them like this. It's going to help us later. Okay, I know z is caught between the xy plane and this surface. Okay, y, I just have to use this to bound y. So y, if I solve, I get plus or minus the square root of 4 minus x squared. That's solving for y. So I know y is caught between the negative of 4 minus x squared and the positive of 4 minus x squared. And then I just look at x. X is caught between negative 2 and 2. We always want our last one to just be bounds. This will take care of the weird circle feature on the x. All right, we just set up our integral now. We found each part. We projected onto the xy plane to find where it intersects because of this. All right, and then it gave me the circle. The circle gives me my bounds for y and x. All right, so I set up my volume. This is going to be x equals negative 2 to x equals 2. We have y equals negative square root of 4 minus x squared. Y equals the square root of 4 minus x squared. And then z is caught between 0 and square root of 4 minus x squared minus y squared. Anytime I want to find volume, I put a 1 in the integrand if they gave me x, y, and z. And then it's going to be times dz, dy. Just make sure to put these in the right order with our bounds. So there's our integral set up, nice and pretty. If I want to get an actual answer, I'll let you guys get to this if you would like. And as always, if you have trouble, please come see me. We can talk about it, and I can help you get to that answer. Some of these are going to be nuts on some of these videos, but I still can help you get there if you would like. Again, I said this in, I think, the videos in the previous section. I'm going to throw some crazy integrals at you because the idea is if you can do the difficult ones, my middle ground assessment questions won't feel so bad. Middle ground and below. Typically, I'll throw one difficult one on my test, potentially. But nothing like consistently difficult. This one is not difficult. It may feel like, well, actually, yeah, this one's pretty difficult to solve. So we may would want to use a computer program. But feel free to try it. There is a method coming up called Polar. And we're going to do using polar coordinates. And this problem actually would become significantly easier with Polar.